So my name is Mark Wagner. I'm president of the Fox Valley Astronomy Club, and Tony and Layla and I were talking about ATM, and so we were trying to figure out, okay, what's the best way to start talking about this? And so we're talking about the Zoom meetings and things like that. So this is our initial meeting for that. So what I'll do is let's go around and introduce ourselves and maybe give a short um, bio on your ATM experience and then what you're looking for out of these meetings. And then Tony will take over and talk about some of the items for starting up, maybe an ATM association or an ATM lab or something like that. And then we'll just open it up to questions and that. So I'll start off on Mark Wagner. Like I said, I live in Lombard, lived in Chicago all my life. And in the mid 70s, after I started working and had some money, I decided to go to the mirror lab at Adler Planetarium and pushed an 8-inch mirror and made a telescope out of parts and pieces and the Novak mount and the Wolf drive and all that kind of good stuff. And then I followed that up with a 6-inch f4 a little bit later on. And then it's in general for the ATM since then, it's been like adapting things to make the telescopes work better, like building a cradle to hold my big big camera on a 6-inch telescope and things like that. So also like little things like using Velcro to hold things onto your telescope mount during observing and things like that. So, um, okay, so I'll turn it over to Herman.
I I built my first one when I was 16, and I'm not going to tell you when that was, but and then one right after that, 6-inch f12, and I took that one and I actually rebuilt it when I was in Southeast Asia for the war games, and carved out a piece of wood and got a coffee can, put the mirror inside of it, got another coffee can for the other end of the piece of wood, got some pipe and built them out azimuth, and we was able to use that. And from that point on, it's basically been repairing used telescopes that I got or improving the ones I had.
Okay, George.
Hi, my name is George. I am in Batavia. I've been using my scope for about 7 years now, mainly just viewing. I'm interested in this topic because it's something it would just be interesting to me to be part of a group of people. Something I never would fathom have doing in my life, building a telescope. So just discussing it, and I just find it fascinating, to be honest.
Okay, great. Mark Pastor, you're on mute.
Okay, I'm here, and I'm Mark Lombard too, and I know nothing about this, but I'm kind of interested in what it would take to build my own telescope and learning about how you line the mirrors and everything. I would like to make a telescope if I was making one that was light enough for my EOS 100 mount and not too heavy, because everything I got now is too heavy for that mount and it won't work well. So here I am, glad to be here, and thank you.
Hey, great. Dan, would you like to make some comments?
Yeah, well, Dan from Air Morris. I did build the 12-inch stop once. I mean, I bought the mirrors and the mirror mounts, but designed the mount And I also had a equatorial table, motorized table kit. So I ended up building it into the Dob mount, so everything could be, is one piece. It's nice big telescope, 90 pounds. So it's not necessarily easy to get around, but it's nice to have the motorized Dob. And I also do tinker around with stuff. I'll take eyepieces apart, make sure they're all flat back, black painted inside, and things like that, just to try to improve performance.
Okay. Brian, how are you today?
Hi. Yeah, good. I'm Brian Leshin from West Aurora area. I am interested in this because I acquired at a really good price a kind of a pseudo light bridge Dobsonian. It's a truss. Got it for 75 bucks. Didn't think anything of it, had no mount. I was able to build a mount, clean the mirror, and I was fascinated that I got incredible views. So this thing is a bear. It probably weighs 100 pounds all in between the mount, the pieces. I wanted to see if I could actually rebuild it so that the mirror box was a lot smaller. Uh, the struts could be a lot bigger, and that's kind of where I'm thinking. So I'm going to see what I can pick up from this. But
Okay,
happy to be here.
great. Greg Cisco, how are you today?
I'm doing okay. I'm Greg from St. Charles, and in 1980, I built my first telescope. I acquired a 6-inch f8 mirror that was probably 3/4 ground already. I think it was an Edmund mirror, and so I had to finish the fine grinding, and I had to learn how to do a focal test and configure the parabola on the mirror. And I did okay, but in the end, I had to mask the outer 1/4 inch of the mirror. So I really ended up with a 5.5-inch mirror, but I made it, and the telescope served me pretty well for several years. The tube was made out of stainless steel, and it was an equatorial mount with one of those 45-degree Y pipe deals with 2-inch pipes. And it was on wheels, and the bearings for the pipe fittings were all like rubber O-rings and stuff. So I was able to get a pretty good setup, but eventually I sold my first telescope and I bought a used 10-inch Dobsonian, and I eventually converted that into a motorized clock drive wedge. So it was an equatorial mount, but it was a wedge like a lot of you guys have seen with my 8-inch SE. And it worked great. It had no vibrations when you would hit the end of the tube. It for visual, for planets, it tracked perfectly. I was able to get that squared away. The problem is, by the time it was all said and done, it was one of those 100-pound deals like you guys are talking about, and it was simply too heavy for me as I was getting older. And I had a part with my baby 10 years ago, and that's when I got the 8SE. So now everything is 10 pounds, maybe 20 pounds. And yeah, so I've done some of this stuff before, but it's been many years. And that clock drive, to convert a Dobsonian to a clock drive, I think was a big deal. The key was a 360 gear worm drive that was about a foot in diameter, that was made out of solid brass, that I got from University of Michigan for, I think, $75 at the time. And the thing was, that in and of itself probably weighed 30 pounds.
Hmm.
But I was able to find a weld shop in Aurora to weld a hex bolt to the top of the spindle for the worm drive, and they were pretty good at getting it centered. But that was what I screwed the bracket, the piece that holds the telescope, the azimuth part that's now at a 45-degree angle. I made the wedge out of a workbench tabletop that I bought from Menards, and I had like a hand circular saw that I like drew up a design out of a 4x8 or whatever the size of the workbench tabletop is. And so it was like 1.5 inches thick. It was particle board 1.5 inches thick, a regular workbench tabletop from Menards. And yeah, so it was a lot of fun, very successful, but it weighed so much I couldn't use it in the end. So
Mhm.
let that be
Okay,
a
thanks.
lesson to you.
Thanks, Greg. Sean Canine, thanks for joining.
Yeah, hello everybody. I'm here at the request of Mr. Tony Harris. I'm the president of the Kankakee Area Stargazers out in the Southland of Chicago, very far away from most of you. I've been an ATM for like 25 years now. It's kind of how I got into the astronomy hobby in the first place. I'm a moderator on Cloudy Nights for both the ATM and the Classics forums, amongst other things. So I really love building big telescopes. I'm not so much a glass person. I've never made an optic, but I love making mounts for them, and I've done just about every variation, every design of telescope, from classical Cassegrains, Newtonians, to very big refractors. My last couple of projects were a 6-inch f/15 refractor with a D&G lens, where I made the OTA and the mount for it. And then my latest telescope is an 8-inch f/12 D&G that I put on an old DS16 mount that I machined the axes, both axes in a mount to accept taper bearings, and buyer's drives on both axes. And I've had a couple different iterations of those. Yeah, but that's kind of my thing. So I really love the machining part of it. I like building telescopes you can't pick up and move around very easily. My wife does not like that aspect because our garage is filled more with telescopes than it is with cars. But that's okay. I do the cooking in the house, so it's an even trade. So there you go.
Well,
So
thanks
I'm here
for
at your disposal.
yeah. Well, thanks for joining us tonight, Mr. Bob Butwell.
Testing one, yeah, okay, it looks like it's working.
There we go.
Okay, can you hear me?
Yes.
Okay. I got started in about 1960. I ground a 6-inch mirror, then I ground an 8-inch mirror. Then I ground a 3-inch ashtray mirror. And with the help of machinists around the area, I made a pipe ATM standard design 45-degree pipe fitting mount. 45 plus a 90-degree for axes. The stand alone, that stand alone weighed 100 pounds. The telescope itself, I made a fiberglass tube. We did that at my house, me and my dad made about 20 fiberglass tubes for members of the Argonne Astronomy Club. Time passes, and I get out of college and get a family started, and I designed a Ponset mount, which is kind of like a barn door tracker. And ever since then, I've been buying telescopes, but tinkering and repairing, as you know, I didn't think of repairing stuff as ATM, but by golly, that sure is, and been doing that ever since. At some point, I realized I would rather look at the stars than build telescopes. So I'm here because I've been there and I've done that, and I know how to done it. So anybody, I can participate in the conversation. I think so anyway. That's it for me, guys.
So Bob, one of those fiberglass tubes resurfaced this last year, didn't it?
Well, as a matter of fact, I have, yes, one of the tubes that, actually one of the guys signed up for the same class with Homer DeBall, back in Downers Grove, with the Argonne Astronomy Club, and he made his own mirror and took one of our tubes. We made them available to members of the club and friends. And I think in the November meeting, it showed up as I think Stanley Zale's kid inherited it and wanted to put it up for sale or then donated it to our club.
Right.
And at the moment, it's here being worked on. I'm thinking, well, I don't know what I'm going to do with it.
Well, the interesting thing that was contributed to the club a couple summers ago, and I had it here at the house, and we're trying to figure out what to do with it because it needed a lot of work. The mirror needed to be resurfaced, and the mount itself was useless at the time. It got torn up pretty good, and so last year we had some mirrors recoated at Clousing, and that was one of them. And then I brought it in and said, okay, if somebody wants it, and Bob Butwell's eyes like lit up and his jaw dropped. He says, "Where did you get that?" So these telescopes find ways to find people. It's amazing.
It found its way back to me. That's for sure. You could have knocked me over with a feather.
Yeah, it was
I,
amazing.
I was bouncing around the room, as I recall, making a total jerk of myself. But boy, that was so happy to see that, and it reminded me of the old days.
And I tried it out before the mirror got recoated, and it was an excellent planetary telescope.
I wanted to ask you about that. Did you have Mark do a full call test on it?
No, we did not. No, we were gonna. That was one of the options, right? That Mark was gonna do a couple things, but then he got too busy, and then I said, okay, let's just get the thing recoated, and that's when we had, about 4 or 5 of us had mirrors recoated last year. Anyway, I thought that was an interesting story, and
It was fantastic. I've still got it sitting over there and gonna get to it. I just need
yeah.
to run to it. That's it.
All right, thanks. Nick, would you like to say a few words?
Sure. So I'm Nick. I'm in here in Batavia, and don't have as much ATM experience as everybody else. Kind of got my itch into doing this when Greg was kind enough to show me some pip photos of his clock drive stuff on his 10-inch Dob, and that kind of got me thinking about, it'd be kind of cool to make stuff. And then since then, I've dabbled around with pushing some glass. I've gone ahead and added trunnions to a 10-inch Dob, similar to how those big bearings are on like the Obsessions. I've done some repairs of a mirror cell in there, and so I've done that stuff. I like to build. I want to build stuff. Don't necessarily have all the tools, but I also want to do stuff that people don't normally do. So what happens if I 3D print a telescope? I don't care if it works or it has perfect balance, but what's the biggest mirror I could put in there if I 3D print it? What's the biggest, what happens? I just kind of want to play around and just stuff.
Okay. Walter.
Yep. Hi, Mark. I'm Walter, here in Oswego. I mostly only do imaging, so I'm on this call mainly because I find the topic very interesting. I have no experience at all on making telescopes, but like I said, I want to learn. And like Nick, I want to find out what the components of a homemade telescope are and how easy it is to make them or gather them and put them together. So just
And then
looking forward to it.
you recently refurbished a telescope.
I did refurbished the C14. took it completely apart and put it together, but didn't quite make any of the components myself, so not
Okay.
the same thing.
Okay. And then we'll go to Tony, and then Tony can continue on with the meeting topics. So the other day, Tony and I were talking about what we're going to cover with the meeting tonight, and basically he wants to talk about plans to grow the ATM experience in the area. So I'm going to turn it over to him, and then I'm going to take some notes here as well. Remember, we're recording it, so if you want any questions, you can text them or send them or just interrupt and go from there. So Tony, I'm going to turn it over to you.
Thank you very much. I want to say it's a privilege to be able to be here tonight among a group of people who are so interested in astronomy that they actually want to build their own telescopes to see the cosmos. And I got into astronomy when I was in high school, and actually before high school, and built my first telescope in high school. And I was a 4¼ f4. It turned out really well, and I went on to build a bunch of other telescopes, culminating in a rebuild and modification of a Meade 12-inch that I built a mount for. It had the equatorial mount weighed. The equatorial head alone weighed about 100 pounds. It was made out of heavy metal, and I turned it on a lathe, all the parts, and the whole telescope probably weighed 400 pounds. So I had to buy a pickup truck to move it around. But it was a lot of fun.
Yeah.
And it gave, the images it gave were absolutely breathtaking. So, and I've been puttering around and I've been collecting stuff. And so one of the offers I have to make to the group here is that I've got lots of glass, and I'm willing to basically give glass away, assuming we have an agreement that the glass either gets finished or it gets returned. So let's say I've got 6 and 8 and 10-inch blanks, and if someone gives me a deposit on the glass and then they finish a mirror, okay, then they get their deposit back. So or if they don't finish it, then they return the glass and they get their money back. So it's
And
zero.
Tony, just a quick interruption.
Sure.
Mark Christensen couldn't make it tonight, but he let me know that he's got some mirror blanks available as well.
Great, that's good, excellent. Okay, I want to make sure that we don't wind up with a situation where these materials wind up getting scattered and winding up in dumpsters. So that's one thing. There also certainly, like you said, I'll make the glass available immediately. Also, there's been a lot of changes in mirror grinding and techniques and hogging out and stuff like that. And so one thing that I want to see us doing is utilizing the most recent methods and basically finishing the grunt work as quickly as possible with machines and tools that weren't available to earlier generations. I mean, like diamond tools that cut through glass like butter. Okay, 60. The way things worked at the Adel Planetarium was you'd be given two pieces of glass and some grit, and it would take a very, very long time to remove that glass and go through all the finer grades. And along the lines, a lot of people gave up. And so, if we can expedite that process, and then get into the figuring area, which is the challenging part and the really exciting part, then I think we'll wind up with where more people actually finish their mirror. And I think that's an exciting possibility, just to see about getting a class together, getting people together, and we have 100% completion of our projects. Another idea I was talking with Nick about was that years ago you really couldn't get a good telescope fairly cheaply, and since that time, China's came along, and there are a lot of telescopes out there available inexpensively. So why should you build? The intro telescope project would be a 6-inch f8 telescope that you'd make. And nowadays, why would you make that when you could do a mouse click? It's a lot quicker. Mouse clicks are a lot quicker. So the idea is that, but there are other designs of telescopes that are out there that you can't buy. But they have about the same skill set level that would be required to build a 6-inch f8. So there's a fellow optician out in Ohio, Ed Jones, and he's got a design for telescopes that are unobstructed, off-axis, Newtonians, or not Newtonians. He calls them catadioptric, Herschelian, tilted component designs. And so you're able to make your own unobstructed reflecting telescope at a cost that is going to be less than the same or less than a 6-inch f8 telescope. So this is something that you can make. You can't buy them. The design is very compact, and it should offer some very, very nice views. There are also some other telescope designs, a daily telescope that you can make but not buy. And then also another thing I proposed was basically making a single element solar telescope. We're familiar with the H alpha filters, and that type of telescope would not need an achromat. You just have a good quality single element lens that you could make, and then you could feed the light in there into the H alpha filter, and it would produce really lovely views. I do have some BK7 glass for achromats, also for solar telescopes. I have some flint, but the data on the flint is not as definite as for the BK7 glass that I have. So we can also make different types of telescopes. We've got the option, like I said, of traditional mirror telescopes, which is usually traditional way of beginning, but also I do have some glass for refractors, and I think it'd be really great if we're able to utilize some of the new techniques that are available. Also, testing as well is a big deal. Nowadays, there are many much better means of testing than the standard Foucault method. I mean, although that's a standard tried and true method, but we have access to much better equipment and better technology than was available 20, 30, 40 years ago. So I'll open it up for if anyone has any questions.
What is that equipment that's so sophisticated?
Oh, well, what's different nowadays is the testing. In the past, you'd use just the standard Foucault test, but nowadays you can use a modified. It's a Mosby Ronchi test. It's a modified Ronchi test. With a Ronchi test, we have a spherical mirror. You have straight lines, which is great. It's a quick test, but for a parabola, the lines wind up being curved. Well, the Mosby test basically utilizes a Ronchi grating that has curved lines, and when you have the correct parabola, the lines are straight. You know about that, Bob?
No, that's news to me. That sounds like a perfect idea.
Oh yeah. Well, the thing is, once again, I mean, I was over at the Adler, and it took forever to test mirrors. I mean, it took a long time. So you were there waiting, twiddling your thumbs to get things done. And so where with these new testing techniques, it's much faster.
And there's less calculations too, because one of the things I remember is with the Foucault test, you had to measure and do
Right. Well, that is.
calculations.
I'm a big advocate of that being the final test, but there's also figure XP. So you enter the numbers into a spreadsheet, and then you'll definitely know the quality of your mirror, no doubts. So that would be very exciting. We can really crank out some super duper high quality mirrors. Also, of course, spherical long focus mirrors are easier than short focus mirrors, but the short focus mirrors, new techniques have developed, and I mean, Mike Lockwood is making f2.5 mirrors, which is just unimaginable. By the way, you really it's expensive to buy a 2.5 mirror. Dr. Mark Christensen made a 6-inch f2.8, which was quite an extraordinary achievement, and he used it to in conjunction with a chroma corrector and got really amazing images. That's something else. Actually, that's something else that's really exciting is that if you want to be bold and brave, you can try to make some of those a faster mirror that you can't really easily buy, or if you did try to purchase it, it'd be very expensive, and use that for an astrographic imaging telescope. Also, short focus visual telescope too.
I figured there had been changes to the art.
Yes.
Glad to hear it.
Well, another example is diamond cutting tools. John Abrahamian, he was a telescope maker with the Naperville Astronomical Association. The club requested that he make the 16-inch mirror for their observatory, and he was given a blank that was 3 inches thick, which is crazy heavy. I mean, that was the old school. I mean, that weighs 60 pounds, 65 pounds, would take forever to cool down. And so he took a diamond cutting tool and a surface grinder, and he removed about an inch of material he thinned out the blank, removed an inch of material in about maybe 1 or 2 hours, which is just, yes, exactly, right. I mean, I spent forever grinding 2 16-inch mirrors. I mean, it was like forever.
That's a lot of glass. Yeah.
Yeah, it's an amazing amount of glass that can be removed very quickly. And I haven't worked with diamond cutting tools on optics, but I was using a diamond cutting tool when I was rebuilding my foundation last year, and I was amazed as to the way it cut through hard concrete. I mean, I've worked with concrete in the past, having removed things and cut things with it, and it was really hard. These diamond cool tools are amazing. It's just astonishing.
That was about the time that I went off to college. The Argonne Astronomy Club had bought a bunch of Maksutov blanks, and the corrector on that has a very very deep meniscus shape to it, and that put an end to it. Just trying to cut that first meniscus. They came pre-pressed from the glass company, and all we had to do was just surface it. But we had an entire machine shop at our disposal, and we tried to figure out how we were going to hog out a bunch of glass, and we did it, but it was early in the year. That was like 1962. We were just beginning to use diamond bits to do that, and it wasn't diamond grit. It was little pellets of. In fact, I don't think it was diamond. It was carbide at the time. Yeah.
Sean actually has had one of those Masutkovs, and I've got a kit. I've got one of those kits.
I've actually had like 3 of them in total. The optics for one, and then 2 others in assembled tubes. Yeah, they're something else. They work really well, but man, they are hard to set up, And I was gonna say there's John Pratt of JP Astrocraft out in Charleston, Illinois. He's got a Bridgeport mill with a rotary table that he has set up with a diamond bit to do the hogging out of his mirrors, So he can do in an hour what it takes, 6 months of hogging to do, and then the grinding doesn't seem so bad after that. But man, watching like a 16 or 24-inch disc of glass go around on the rotary table with the diamond saw going at it is just something else.
Yeah, it's astonishing. And how quick it is nowadays. Yes.
Yeah.
And that's the key to being successful in achieving the goals is that if it's going to take you couple of months just to get the grinding done, that's going to be a real big deterrent. But if we can use modern methods and techniques and reduce the amount of time, then we'll see more people succeed in their goals. And I think that there's a certain amount of it's not just pride, but it's a demonstration of devotion and to the and also trying to actually make a telescope that's probably better than some of the things you could buy. I mean, the telescopes have gotten a lot better. The ones you could buy, they have gotten better. But I think that we as amateurs, we possess the critical element of time to be able to devote and get a very good parabola or spherical surface, if the case may be. So hopefully we'll be able to make some telescopes that not only are not available commercially, but also will function as good or better than anything else that's out there.
Yeah, I think one thing, you guys might want to think about is, setting up testing rigs. Like you talked about it earlier with the Foucault test, and I don't recall the other test you were talking about, Tony, but
Rocky.
Ranchi, yeah. So, people are in the hobby all over the place are doing double pass auto collimation testing. And this is more than just for Newtonians, for the refractors as well, to kind of get an idea as to how they're performing or to see if they, paid a decent price for a decent optic. When you're spending more than $2,000 or $3,000 on a refractor, it's nice to know, if you got your money's worth, kind of a thing. Now to do those kinds of tests, you need, flats that are larger than the optic that you're testing, right? So finding a flat over 10 or 12 inches is a really big deal these days. Like those things are worth their weight in gold,
Yeah. I've got a 16-inch flat that's very good out to about 12 or 13 inches, where it's 10th wave and then it's quarter wave out to 16.
Right. So yeah, so that's yeah. So, but setting up a rig, you need a pretty long room. You'd want to control the air currents and have it temperature controlled and that kind of thing, so that you can put an optic in and get a decent test with a knife edge, maybe with a camera attached, and for those who aren't interested in, taking the time to grind the glass and stuff, I'm sure you'd have a lot of people interested in seeing how their scope does. You can test any kind of scope. You can test Newtonians and, just about anything with that kind of rig, provided you have enough room to get a focus. But yeah, that's something to think about, and that way you kind of open the ATM up to people that normally wouldn't consider that kind of thing.
I intend to make glass and materials available immediately. However, I'm hoping that we as a group can maybe see about putting out feelers, seeing if we can find a maker space where we could set up something permanent. I've got a number of machines that I'd like to see, that I'd like to be able to donate to a maker space or mirror lab. Well, I mean, we would be developing the mirror lab. But I've got a 2-spindle machine. The machines are older; they need to be cleaned up and greased, but they're fully functional. Sean, do you have any idea how we could find a makerspace that could accommodate us?
That's a good question. There are maker spaces out there, but you kind of want one kind of devoted to telescopes and how they're made. They have such special conditions. A lot of maker spaces are devoted to either working on your car or doing woodwork, and woodwork is great, but doesn't play well with sensitive optics in terms of dust and things like that, right? So, working on telescope stuff does have its special conditions, Tony and I have been talking about, what kind of space to look for, and one thing to think about is, because telescopes can require some crazy equipment, how you want to go about organizing the space in terms of, do you make it a LLC or a 501c3? so that you can have the entity, you know, be the legal leasee of the space. If you wanted to go out and get a space on your own, you know, you'd have to think about, you know, do you have the financial resources to lease a space for what would probably be 2, 3, 4, 5 years? The insurance that goes along with that, paying for the power, you know, that kind of thing. If you have some specialty equipment like a Bridgeport mill, you need 3-phase power electric going into it. And honestly, all that stuff sounds scary, but the only really hard part is getting the insurance, because they're going to ask questions like who's using these equipment. You know, if you're grinding glass, you need to worry about how the glass dust is being taken care of.
So long as so long as you've got water, you're fine.
Right, but you have to, you know, people that work at insurance companies probably don't make telescopes or grind glass for a living, so they're not going to understand how, you know, these processes can be managed, right? We'd have to convince them. That's why I said it's the only tricky part, I think, in the process. You know, if you have 4 or 5 very committed individuals who wouldn't mind being on the board of directors, basically, for this either LLC or 501c3, and it'll have to be a 501c3 because that's the only designation. There's a lot of different 501s, and most of them are pretty cheap to organize. 501c3s are the expensive one because you can own real estate. So, you know, you kind of want to, it's a lot to think about how properly you want to do it. Now, if you want to do it improperly, okay, nobody has to know about it, right? You find somebody with who's on our side with a bit of space that we can rent kind of under the table, you know, and then nobody has to know what we're doing in there, and everybody gets a key,
Hello?
et cetera, et cetera.
Hello.
Hello, this is Lalit.
Hi, Leila. How are you?
Okay. I have been trying until now to join a little bit.
Welcome to the group.
Yeah, so that's a start of it, you know. I could go into more detail, but I don't want to put anybody to sleep.
So,
So
Sean, I think your points are right, because I've written down a whole bunch of stuff like that, and it depends on, like you say, you know, how do we want to approach this? If it's in somebody's garage or you know, basement or something like that, that's one thing, right? And maybe that's the way to start this, because the other way, you may run into so many roadblocks you'd never get it started, never get permission to do things. You know, you have expenses out the wazoo. And I think that maybe what we do to start is you have, you know, some mirror blanks maybe that are close to figuring, and maybe, you know, your first foray is, okay, who wants to build a telescope? Let's say in this group of 13 or 14 people here, okay, 3 or 4 of us want to build a telescope. Well, okay, let's do it. And then as we're doing it, you know, have these monthly meetings or something, and just keep on with the administrative part. How can we expand it or take it to the next level? Because I think
yeah, that's a great way to go, because that way you're gauging interest and you're not making any financial commitments
right.
that, you know, somebody's going to be on the hook for 3 or 4 years from now when everybody decides they just want to buy sea stars.
Right. Well, the thing is, Tony, is like, okay, so like your idea with the blanks, that is, so it's up to the individual to put the money in, right? So it's just for the blank. It's not for anything else, right? So it's kind of like you don't have a sunk cost or a monthly cost that has to be borne by a group. Okay, how do you get that money back? And we're not all philanthropists, and you know, okay, yeah, everyone just do it. So but you know, if I put myself in the place of, okay, I just want to build a telescope to have that experience, and if we have the blanks ready, you do some figuring and testing, and right, I mean, that's then the figuring and the final shape is not that big a deal if we have blanks ready to go.
Another thing also is that the testing, if you're trying to do it just from a book and not without someone to show it to you, it's a little bit more confusing. But once someone shows you how it works, and to understand how the shadows, it's really very straightforward. It's easy. You're muted, Mark.
Sorry about. Maybe one of us is the testing person, sets it up at their house or the garage or whatever, right? I mean, this is the kind of stuff that maybe you share with the group. Like, okay, so somebody else, like Mark Christensen has said, that he is willing with his lathe and stuff to make blanks for the no, I'm losing my train of thought, for the Dobsonian box and truss and stuff. Okay, he would, but somebody else has to do all the fine work, but he could get the parts to that. And so I think the other part of this is, does somebody have availability with CAD so we can do drawings of this, or we're not doing it like on the back of an envelope, that type of thing. Signs.
One thing that would be great would be if we could find first of all, someone who has expertise in CAD, and then actually find a local wood shop that would be willing to cut the pieces at a reasonable cost. And then it's just a matter of sanding and screwing and gluing and painting.
Right. And that's, again, Mark Christensen offered to do some of that. So that's one path. I think the other one would be like someone who's not going to build a telescope, but maybe has some experience. And I'll say, look, okay, someone like me, is that person is like the procurement person. Okay, here's all the sources for flats, for spiders, for mirror cells, and do all that work up front as well. So that, okay, here's where you can go. Here's like 4 places you can go to get all these other accessories to finish out your tube. That type of thing, just so that, because I know, like, if you're coming into it blank, okay, now what do I do? So I had the mirror, now what do I do? But have that like a little handbook. Okay, here's all the stuff you need to know. And again, then you can do your own budgeting and your cost of what you might want to make. So big difference between making a 6-inch and an 8-inch from a cost standpoint too, because everything's bigger.
And I'll tell you what, too, from my perspective, because I love to build mounts. But what I hate to do is put together drives, and specifically the electronics for the drives. Like me, I'll use a 12-inch buyer's gear, an 18-inch buyer's gear, and run it off a little timing motor, because the thought of having to put together a stepper driver just puts me in an apoplexy. So having an electronics person who can do on-step drives, or that kind of thing, that's invaluable as well, right? And then if each person, you kind of compartmentalize these skills, it allows each person you're going to kind of be able to work with the schedule too, so you're not dealing with 16 people at once.
Right.
So,
and I think that brings to mind what another thing I wrote down was, okay, I think it might be a good idea to go across the different clubs in the area, like
Yes,
like Naperville, like Northwest Suburban, et cetera, et cetera. And so, take this, and maybe Tony and I and maybe somebody else approach the other clubs and say, hey, we have this group. Would you like to join this group? And here's the reasons why and the parameters of it. Like Sean said,
regional astronomy club.
I don't know enough about electronics except how it all works together, but to fix it or design it, that leave it up to an expert.
Oh, and that's really important, because a lot of times, I think we've all seen that the recommended procedures on cloudy nights, it's just not the same as actually being able to talk with someone and see what they've done.
Right. I think there's enough individuals around the area, and this is a good cross section right here of people that have built telescopes and know a lot about stuff and different components of
And I've got the experience to tell you what's going to go wrong.
it. We all have that, right?
Yeah. So, and hopefully we'll see some successful projects come out of this then. And also, if this takes off, which I hope it will, I'd like to see if we could figure out a way of expanding this and getting some high school students to build their own telescopes and do some sidewalk astronomy.
Right. Right. Yeah, that was the other thing you and I talked about. That would be the goal down the like a stem, or what do they call it? STEM or now or
Mhm.
Yeah.
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 Last night I was looking through. I had a request for someone was looking for an article in some old issues of Sky and Telescope. So I was looking through some 1970 issues of Sky and Telescope, and I nearly fell over. There was a high school student who built an 8-inch refractor in high school.
Mm.
It was like, wow,
Wow.
yeah, wow, and it worked. Yeah, it was amazing.
And that man was Roland Kristen. Yep.
So, yeah, but it's just, yeah, no. So I think that there's a lot of value in being able to make and create. I mean, it's the driving force of science is just to make instruments that can do more and see further. And I think that it's important that young people develop those skills because, you know, um, it builds a lot of character too in terms of being able and pride to be able to build something and then show your neighbors the rings of Saturn or the craters on the moon with a telescope that you made. I think for young people, it's very powerful.
You and I talked about that part, and to keep that part as simple and inexpensive as possible, but still high quality, so that when they complete it, they can use it.
Sure. Oh, and that's another
Right.
thing.
I mean, that's the big thing is that so if this develops, we develop something that is successful, that somebody will be able to make the telescope.
That's another thing we talked about was the fact that some aspects of telescope making have gotten really good. Others have gotten out of control. Like illuminized, getting mirrors illuminized has gotten really expensive. But there are techniques of silvering mirrors, which we discussed, and or also possibly if we get a space, we could. I do have a friend who's got the parts for an illuminizing machine, and so we could if we do that, on our own, it'd be a lot cheaper because the price for illuminizing mirrors has just gotten crazy expensive.
Okay, this sounds good. Layla, oh, he's not on again anymore. He's
So
on,
he's there.
off.
He's there, but he's invisible.
Yeah. So I guess, okay, so how often do you want to have this Zoom meeting to start out with? Like once a month?
Sure.
I can host a Zoom meeting on this Wednesday of each month. What is the fourth Wednesday of the month? Yeah.
So,
Because we were doing the imaging group like last week. So we're doing that on the third Wednesday of the month. And if you want to do this on the fourth Wednesday, I'd be glad to set it up. And then maybe tonight we can have maybe 4 or 5 things to do to progress to the next meeting. So that, we progress down this. Okay. So like, for example, Tony has an inventory of mirror blanks. Mark Christensen's having an inventory of mirror blanks. So start from there, maybe. What machinery is out there, and then maybe on the other side, okay, who's really interested about almost being the guinea pig to make a telescope at this point amongst our group, and so we can come up with processes and procedures for it.
Also, I'd like to.
I don't want to have it where we start and then 2 months later we're not doing it anymore. So if we want to commit to it, let's commit to it. If not, that's fine as well.
One thing that comes to mind is putting the link on either on the Fox Valley site to some of the other telescope designs that are out there. If some folks want to consider those other designs, or if they just want to begin by making a 6-inch f8 or 8-inch f6 telescope or any other ref ratio, we could certainly set them up for that.
So let's do an inventory of mirror blanks. That would be one thing, right? And then links to telescope designs. And maybe an RSVP amongst us. Who wants to build one? Who wants to build a telescope? Kind of like I said, be the guinea pig on starting this out.
Sure.
And then
Also,
maybe an inventory of skills.
Also, if we were able to maybe find out if some folks want to host, when it gets a bit warmer, host some telescope making in their garage. One of the things that at this point in time, I've got abrasives to help move us along, but let's see. So I could do the inventory of glass. Also, that I guess if people do want some glass, then the next thing would be to line them up with making a hydrostone tool. In the past, you used to use another piece of glass to grind the mirror, but that's just wasteful. And hydrostone tools, should work faster than the traditional methods as well.
And I think Lilith had talked about that as well. So I'll put a note for that.
So once again, folks, I have glass. I have plenty of 6 and 8-inch blanks, and a limited number of 10s. These are the old school, so they're kind of thick and heavy. But once again, they're available for free with a deposit. So you finish the mirror, you get your money back. You don't finish the mirror, you give the glass back, and you get your money back.
Okay. And then can I ask you then to get a hold of Mark Christensen and see what blanks he has?
Sure.
Okay.
I'll mention to him the idea as well with the deposit.
Right.
The whole idea behind the deposit is we just don't want to lose this glass. Has gotten pretty difficult to find and expensive, and we don't want to lose it. So if someone starts something and doesn't finish, it's no harm, no foul. Just right. So long as the glass doesn't wind up in a dumpster.
Okay.
So when we were talking about who wants to be like a guinea pig, I've got a 6-inch blank and a 12-inch blank. I have hydrostone. I have grinding. I have grits. I don't mind doing it, but my biggest thing is I don't want to sit there and grind for like 6 hours, realize I did something completely wrong, and then be like, well, time to have another 7 hours with this stuff. It would be great if somebody who has a little more experience can sit there and overshoot or overwatch what I'm doing and be like, no, don't do that. You're doing something stuff, so I don't waste my time.
Yeah, that's a big concern. But yeah, I'd be happy to help out, of course.
Like, so if anybody wants to be a guinea pig, I'm going to do it no matter what. So regardless of anybody else, and if anybody wants to like meet at somebody's house, work in their garage or whatever, that's fine. It's just, I just don't want to be like, hey, I'm trying to learn how to do this. And part of me is like, yes, I want to learn the 6-inch blank, but if I did, if it took me stupid hours worth of work to do the 6-inch blank, then I'm never going to touch my 12 because it's going to be worse.
So maybe have a watch party, not meaning that we stand there and watch you do this, but have an hour or two session, like you say, and everyone gets educated on it. Maybe everyone gets a chance to push the glass a little bit and see what it's like,
Yeah. There's the thing about this is that a lot of people folks do in fact have hesitation and trepidation, and things have gone wrong, but once you see the way it's done, it's like falling off a log. If you've got someone there to help a little bit, it really is like falling off a log. It's not hard at all. It once you've got the right techniques down, everything comes along really good.
Yep.
But I do want to say that there is also Murphy's Law. I did recently loan a telescope I loaned a tabletop Dobsonian telescope to a friend. gave him instructions on how to use it. And the telescope has a 1.25 focuser that's got a screw-on 1.25, but then the 1.25 screws in onto a barrel that measures 1.5 inches in diameter. And so my friend took the telescope, and instead of pulling out the dust plug, he unscrewed the 1.25 adapter, put the eyepiece in, and the eyepiece shot down the barrel onto the mirror.
I don't know why every time you have to bring that up every time we're in front of people. I just
It wasn't you. Don't worry about it.
honestly, you make one mistake. This is why you don't drink and observe, okay?
Wasn't you. Wasn't you. But yeah, I mean, in all my life, I never thought that anyone would do that. Yeah. The mirror is okay. The mirror has a little chip on it, but it's fine. But so anyhow. So once again, I want to extend the offer of free glass with a deposit. And no, I won't take your deposit to the horse races, okay? So just finish the mirror or return the blank if it doesn't pan out. But I want to encourage people to try something.
And if anybody wants to know how to build all the other stuff, the spider, the cells, how to mount your tubes to the walls or anything like that, I'm happy to help in that respect.
Oh, one more thing. There is, if you're going to go with a traditional type scope with a tube, there's Hastings aluminum irrigation tubing out in Nebraska. Wonderful, wonderful aluminum tubes, but they tend not to. The shipping is expensive, and they usually wind up getting crushed. So the other option is here in Chicago. There is spiral paper tubes from Chicago Mailing Tube. They're really beautiful tubes, strong, 1/4 inch thick. You can drive a truck over them. Very strong and thermally stable as well. So they're really good tubes. Paint them up; they look fabulous.
So I have one of those aluminum tubes on my 8-inch F5 from way back when. And just an FYI, I've got the cork lining, so all the heat is dissipated outwards. And I've got scores of holes drilled in it for all different things that I mounted onto the telescope, guide scopes, piggyback stuff, eyepiece focusers, whatever it is. So the aluminum tube is really good. And then you just put electrical tape over the holes that you're not using to keep the dust.
The main thing about the tubes here in Chicago is it's local. They're close. I mean, they're 15 minutes away from me, and they're really cheap. I think a 6-inch, a tube with a inside diameter of 7 inches, 1/4 inch wall thickness, 50 inches long. I think it was like $35, $40. That's your shipping cost for Hastings for that tube.
Can I suggest maybe putting together a groups IO
Sounds good.
group for this so that we can all have shared emails and shared calendar invites and all that kind of stuff?
Yep. I can do that. I'm not sure with the details, but somebody can help me do that. Yes.
Yeah, we did that for our club when we lost our website, and it's a piece of cake.
We use we use it as well. Yeah. But we won't call this any particular astronomical club. We'll keep it as a separate.
Oh yeah. How about Illinois
Midwest ATM or something like that.
Illinois ATM.
There you go.
You're talking about everybody in Illinois.
Well, I think
you got to Google it first. You don't want to.
The problem with that is then somebody thinks you have an ATM at your house. So
that's right.
International Association of Tour Managers.
Yeah.
Sorry,
come over here and get your deposit from Chase, no problem.
Right.
Well, there's also the IATM, the International Association of Transport and Communication Museums. Now, you thought we were niche. So there you go.
I would say we want to say Greater Chicago Metro, the telescope makers.
Yeah, we'll figure something out.
Yeah.
But no, that's a really good idea, Sean. Yeah, it works great. Okay. So I'll set up a meeting for a month, fourth Wednesday in, that's February 28th, looks like. And
Oh, I just want to conclude, say one last thought is that the test I was describing, what's fabulous about it is that we've got someone who can do the print, it's just regular printing onto a transparency with that modified Mosby Ronke test, and so this means that people can work on their telescopes in their basement on their own time and have a precise method of knowing how good it's going to turn out. So they don't need a fancy test apparatus, just a light source and a Ronke grating, and they'll be able to do precision work. And of course, also we'd be able to help them out as well.
well, I think these are all good subjects for future meetings as well, right?
Yeah.
So today was a good start, I think. We had a lot of background and some good ideas. And now it gets down to, okay, how do we make this work so it doesn't lose momentum and it doesn't fall on just, a few people to keep it going. I'm looking forward to it. So I may decide to make another telescope, just what I need.
One last thing I want to throw out there is that for the folks here, if you know of anyone who's interested or a young person you'd like to work with on this, encourage them and see if we can expand the group right away.
Yeah, and when you get the meeting notice, just pass that on.
Sure. Thank you very much, Ron. I mean, Mark.
Yeah, no. This will be fun to do. I'll open it up to everybody again. If anyone wants it to add on to this or ask any questions, go right ahead. And if you want to, maybe not commit totally, but say, hey, I might be interested in helping this out with the group.
I wish Mark were here because I know that he had acquired a potter's wheel that greatly facilitated him making optics.
Well, again, what we could do, Tony, is just we'll contact him.
Sure.
He can make it tonight because he's been so busy. He gave a talk last night for Wayne State University, I think, and he's got a bunch of other stuff. Otherwise, he'd be here. But so I'll leave that up to you, Tony, to contact Mark and let him know what we're doing on here, and maybe also with Layla because you guys are have probably the best line on the equipment.
Okay, very good. So you Mark, you want to sign us off?
Sure. Anybody else want to say anything or ask any questions? Thanks to everybody for coming out tonight.
Thank you. This has been interesting, at least. I enjoyed it.
Thank
All
you.
right.
You all.
As
Glad I
well,
was
thanks,
invited.
guys.
Clear
Thank you very
skies.
much.
Clear skies, everybody. See you
Thanks,
later.
guys. Bye-bye.
Bye.
Looking up.